Hello everyone. Today we will be presenting about our high-rise building. Before starting our presentation, let me introduce myself and my partners. My name is Karuniko Aryadana Lim and my partner is Juan Carlos Darwin Saragi. We are from Group 7. Well, in this presentation, we are going to discuss about Shanghai World Financial Center. So first, we will begin with the introduction, history, and architecture about Shanghai World Financial Center buildings. Introduction. Shanghai World Financial Center is a super tall skyscraper located in the Pudong district of Shanghai. It's a mixed-use skyscraper consisting of hotels, office, conference room, observation deck, and shopping malls. The story about Shanghai World Financial Center. The tower foundation stone was laid on 27 August 1997. In the late 90s, the Pierre de Smet Building Corporation suffered a funding shortage caused by the Asian financial crisis of the 97 till 98. We stopped the project after the foundation were complete. On 13 February 2003, the Mori Group increased a building height. The new building used the foundation of the original design, and construction work was resumed on 16 November 2003. The building reached its full height of 492 meters or about 1,615 feet on 14 September 2007. After the installation of the final steel girder, the final cladding panels were installed in mid-June 2008 and elevator installation was finished in mid-July. The Shanghai World Financial Center was declared complete on 17 July 2008 and was officially opened on 28 August 2008. And furthermore, there are companies involved in the development of Shanghai World Financial Center. The developer is Mori Building Company. Architect is Mr. Con Pedersen Fox. Structural Engineering, Leslie A. Robertson Associate RLLP. Main contractor, China State Construction, Engineering Corp. And Shanghai Construction Group General Company. The architecture of Shanghai World Financial Center. The most distinctive feature of the Shanghai World Financial Center design is the trapezoid aperture at the peak. The original design specified a circular aperture, 46 meters or about 151 feet in diameter to reduce of the stressness of wind pressures and to reference the Chinese mythological depiction of the sky as a circle. It also resembles a Chinese moon gate with circular from Chinese architecture. However, the initial design began facing protests from the mayor of Shanghai, Chen Liangyu. Then the architect suggested a bridge be placed at the bottom of the aperture to make it less circular. On 18 October 2005, KPF submitted an alternative design to Mori Building, and a trapezoidal hole replaced the circle at the top of the tower, which in addition to changing the controversial design, will also be cheaper and easier to implement, according to the architect.
Okay, high-rise building structure system. Shanghai World Financial Center is generally a composite structure because it combines the use of concrete and steel in its construction. On the observatory floor, it's built with a steel frame structure system with trapezoidal holes in between. This main structure is designed like this to support the strain and load that works on buildings derived from internal force and external loads, such as earthquakes, storms, and wind. The shape of the tower is designed to be trapezoidal with the same side length of 58 meters, cut with two bows moving from top to bottom until the two bows are united so that the six-sided building. This form aims to respond to voltage in the best way and optimize the materials used. The shape of this building also changes with the change in height. In addition, at the top of the building, there is also an inverted trapezoidal tunnel that serves to reduce the force of the wind received. The structure is planned to receive earthquake force up to 7 Richter scale. In tall buildings such as Shanghai World Financial Center, the weight of the building greatly affects the structure of the building. The lighter the building will be, the better at receiving the load of the earthquake. To reduce the weight on this building is carried out several steps. Among others, shrink the thickness of the concrete shear wall, enlarge the stiffness of the lateral load-bearing system at the perimeter of the building, using a steel frame at the top of the building. The use of outrigger truss is like a knob to transfer force from the core. The size of the building decreases as the height of the building increases. At Shanghai World Financial Center, there are three main structural systems. The first is the mega frame structure. The second is the reinforced concrete and brass steel surface core. And the third is the outrigger trusses. Technology. Tune mass dampers (TMD). As we know, high-rise buildings are prone to receiving wind or earthquake loads. The higher the building, the stronger the wind. The higher the building will make it heavier so that the force of the earthquake will be greater. One of the methods developed to receive earthquakes is to use dampers to control the response of structure that receive earthquake loading by dissipating earthquake energy through dampers installed on the main structure. One of the energy absorbing system is the turn mass damper. TMD is a tool consisting of mass, spring, and damper placed on a structure with the aim of reducing the dynamic response of the structure. In this building installed two mass reducers consisting of 150 tons of counterweight on the 90th floor to improve comfort in strong wind condition by minimizing the shaking that occurs. Advantage of structural system. The first is earthquake resistance, the second is resistant to wind, and the third is easier load dispensing. The next is substructure. The megastructure concept was shown to withstand the strength of typhoons, winds, and earthquakes. Three parallel structural systems were used: megastructures consisting of structural main columns, diagonals, and bell trusses. Shear wall located at the core of the building. Outrigger trusses, interaction between concrete walls and mega columns. Due to the architectural shape and limitation of the existing stake foundation, the new structure system is designed to reduce structural costs and further accelerate construction. To improve the quality of office space located on four fronts of the building, the new structure system minimized the limit with 17 columns wide to 3 narrow columns, so that the residents of the building can see the beautiful scenery in Shanghai City without being hindered by many columns. Diagonally from the megastructure is formed from a structural steel box. The steel box is filled with concrete, thus providing increased rigidity, nonlinear structural behavior, and structural damping. The advantage of concrete filler is also used for the top of the building, where it is used to improve the shear stress connector and stabilize against the bend of the steel plate. The columns of megastructure are a combination of steel structures and reinforced concrete. On the connection from mega diagonal to column, the steel column should be able to transfer vertical components from diagonal load to composite column. When a steel column is transferred, the load around the concrete, the steel column must be strong enough to shoulder the iron construction load on it. This is done in accordance with the building codes for tall buildings in China. Finite element analysis. Foundation structure. The building is supported by a lattice-shaped foundation wall, consisting of an external wall and a core wall at the base of the tower. The pressure-resistant plates are more than 2 meters thick and supported by stacks up to a depth of 78 meters in the ground, equipped with 2,200 steel pipes. For casting concrete plate foundation is used one of third mixture polycarboxylate. Substructure related analysis. This main structure is designed like this to support the strength and load that works on buildings, derived from internal force and external loads, such as earthquakes, storms, and wind. The shape of the tower is designed to be trapezoidal, with the same side length of 58 meters, with two bows moving from top to bottom until the two bows are united, so that the six-sided building. This form aims to respond to fault ache in the best way possible and optimize the material use. The shape of the building also changes with the change in height.
So, next we will discuss about the infrastructure of the Shanghai World Financial Center. The first one is column. The column of the mega structure are mixed structural steel and reinforced concrete. At the connection of the mega diagonal to the column, the steel column must be of size capable of fully transferring the vertical component of the load in the diagonal to the composite column. Above and below this connection, the size of the steel column is reduced away from the area where the steel column transfer loads to surrounding the concrete. The steel column need only be strong enough to carry the construction load of the cell work above and to meet specific requirements the building codes that govern and guide tall building design in China. Second one, floor plate. The floor plate structure system in this building use diaphragm system. The diaphragm is a system structure used to transfer lateral force. The diaphragm usually works double as a floor system or roofing system in a building where it also accepts the style of gravity in the building. At the Shanghai World Financial Center building, use diaphragm formed from plates reinforced concrete. The last one is elevation. In September 2011, Mitsubishi Electric Corp announced that it had won a tender to build the Shanghai World Financial Center lift system. Mitsubishi Electric will provide all its 106 lifts, including 3 high-speed models capable of traveling at 1,080 meters per minute. By the end of December 2011, the base of the tower had been complete and steel construction had risen above the 30th floor. Method of implementation of construction. The groundbreaking of the Shanghai World Financial Center was held on 29 November 2008. After the tower has passed development environmental impact research, the tower will use sustainable technique to make the building welcoming environment and reduce energy use. At the end of April 2011, the tower steel reinforcement has risen to the 18th floor. Meanwhile, the concrete core that has reached the 15th floor and the floor framing has been finished up to 4th floor. At the end December 2011, the foundation of the tower has been complete and the steel construction has been complete rises above the first floor. By early February 2012, the core metal tower has risen to a height of 230 meters, or is about 750 feet, with approximately 50 floors to be complete in the first month of 2012. Cracks start appearing on the ground near the tower construction site. This has been blamed on land subsidence, which is likely caused by excessive water extraction in the Shanghai area, not by the weight of the Shanghai World Financial Center. Technology and material construction. Building structure, the Shanghai World Financial Center features a distinctive diagonal braced frame with exterior and core walls. With the tower weight distributed on the mat slab, the building is additionally supported by 2,300 steel tubing bearing piles insert up to 78 meters into the ground. Use insulated glass unit with silver high performance coating to meet the highest aesthetic, agronomic, and environmental standard. Horizontal metal fins complete the curtain wall, adding depth, rhythm, and a sense of scale. Glass coat reinforced concrete and steel structure using intermediate layers of DuPont. Upper structure related analysis. At the top of the building, there is also an inverted trapezoidal tunnel that serves to reduce the force of the wind receive. The structure is planned to receive earthquake force up to 7 Richter scale. So the next we will discuss about gallery and DET or detail engineering design. As you guys can see the picture of the structure of Shanghai World Financial Center is the upper structure of Shanghai World Financial Center, and this one is the column from Shanghai World Financial Center, and is this trapezoidal tunnel in the top of Shanghai World Financial Center. Next one is more information about Shanghai World Financial Center. Building name, Shanghai World Finance Center. Location, number 100 Center Avenue, Pudong New District, Shanghai. Area, 30,000 meter. Height, about 492 meter. Structure, composite between reinforced concrete structure and steel frame structure. The office tower features a distinctive diagonal braced frame with the exterior and core walls. With the tower weight distributed on the mat slab, the building is additionally supported by 2,200 steel tubing bearings piles insert up to 78 meters into the ground. The substructure used by the Shanghai World Financial Center has carried out 4 tests of wind loads. The first one is force balance test for structural rods or structure strength, and dynamic response or human comfort. The second is pressure test for the development of steady state and the dynamic pressure and suction on the facade or for the design of the facade. The third is environmental test for windiness in the streets and country yards. The last one is aeroelastic test for structural roads. Thank you very much for your great attention. Goodbye.